What's up, 7th grade? Mr. Agnos here. Today we're going to be talking about something called repeating decimals, and this does tie into fractions that we've been working with quite a bit this year. I think you've probably seen repeating decimals before, but now we're going to take a look at exactly what is going on with them. So one thing that I have told you guys this year is that when we write a fraction, we're actually writing a division problem. So before I get to this problem right here, let's say I have the fraction 2 fourths. This is actually a division problem. It says 2 divided by 4. And so if we want to convert this into decimal form, we say 2 divided by 4. Now, since 4 doesn't go into 2, we have to put a decimal point here and then some zeros. I usually start with 3, and then we can add more if we need them. Remember, these zeros don't change the value of this 2. All right, so I say 4 goes into 2 0 times. 0 times 4 is 0. 2, bring down the 0. Remember, my decimal point is now going to go here. 4 goes into 20 5 times. 5 times 4 is 20. I subtract, and I get 0. I'm going to put the 0 in red. I get 0. What that means is a remainder of 0. So 2 fourths in decimal form is 0.5. And when we do the division longhand, we end up with a 0 here. Well, that isn't always the case. Sometimes we go into divide numbers and we never end up with a 0 here. We're continuously just dividing over and over and over again, and we call those repeating decimals. So there's probably one repeating decimal that you guys are familiar with, and that's 1/3. So again, this means 1 divided by 3. So if I want to figure out what this is as a decimal, I would say 1 divided by 3. All right, the number on top always goes inside the little house. And then I'm going to add my extra zeros. And I always start with 3. Again, if we need to, we can add more. Okay, 3 goes into 1 0 times. 0 times 3 is 0. 1 minus 0 is 1. Bring down 0. Okay, let's make sure we put our decimal in the right spot. 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. So I brought down my first 0. Now I'll bring down my second 0. 3 goes into 10 3 times. 3 times 3 is 9. Wait a minute, that looks familiar. 10 minus 9 is 1. I'll bring down my third 0. 3 goes into 10 3 times. 3 times 3 is 9. And you guys can see what's happening here. We're stuck in an infinite loop. I'm just going to keep bringing down zeros, right? I'm going to write more zeros here and keep bringing them down, and I'm going to keep getting 3s up here. So we call this a repeating decimal. This process is going to go on forever. So 1/3 is equal to what we call 0.3 repeating. And we have a special way to write that. I can't write an infinite string of 3s here, so what we do is we do 0.3, and then we put a line over the part of the number that repeats. So in this case, the 3 repeats over and over and over again, so I put a line over it. And this tells anyone looking at this that, hey, these 3s actually go on forever, right? This is actually 0.333, and these 3s go on forever. They literally never stop because we're stuck in this infinite loop right here. All right, so let's take a look at this problem right here. It says decide if each decimal is a repeating decimal. Well, the first one that they give us is 7.777, and they have a line over all 3 sevens. Well, what that line means is that these 7s go on forever. So this is actually equal to, and I could do 7s, and they just keep going and keep going and keep going, dot, dot, dot. So this is definitely a repeating decimal. Anytime you see this line, it's going to be repeating. So is this a repeating decimal? Yes. Got it. All right, so then we move on to the second part. Well, this number right here, 8.617, this is just a plain old ordinary decimal. 8.617. there's no line here. There's nothing that tells me that anything repeats. So that's it. It is not a repeating decimal. If you're going to see a repeating decimal, you're going to see it one of two ways. You're going to see it with the line on top, or you might see it the other way I've been doing it, which is you might see like a bunch of sevens and then dot, dot, dot. So what you're looking for is the 3 dots afterwards or the line. Since this has neither, this is what we call a terminating decimal. To terminate means to stop, to end, right? The terminator, he ends your life. That's why he's called the terminator. So this is a terminating decimal. So it is no. Final check. Got it. All right, let me peruse some of these. All right, this one says write the decimal expansion for 6/11. So remember, this is a division problem. 6 divided by 11. So let's go ahead and do this division and figure out what the decimal expansion is. 6 divided by 11. The number on top always goes inside the house, and then I have to add some zeros. 11 goes into 6 0 times. 0 times 11 is 0. And we'll bring down our first 0. Don't forget our decimal. All right, 11 goes into 60 5 times. 5 times 11 is 55. I subtract, I get 5. I bring down my second 0. 11 goes into 54 times. 4 times 11 is 44. 50 minus 44 is 6. I bring down my third 0. Notice that I have a 60 again. Well, I had a 60 right here. So I have a 60 again. So 11 is going to go into 60 5 times, just like it did before. 5 times 11 is 55. And I get a 5, and I would have another 0. And hopefully you see what's happening here. Again, we're stuck in a pattern, except this time the pattern has 2 parts instead of 1 part, right? 11 is going to go into 54 times. 4 times 11 is 44, and so on. This pattern is going to continue forever. So this decimal looks a little bit different than what we had before. I have 0.5454 and so on, and this pattern is going to continue forever. So when you're putting your little line over your decimal, you have to put it over the entire part that repeats. So I would write this as 0.54 and then put a line over both the 5 and the 4. That tells me we have a pattern that looks like this. So I look at my answers here, choice C. Got it. All right, moving right along. Again, I know I'm going fast, but again, you can always rewatch a question. Okay, sometimes they're going to give you a mixed number, and it says you have a pizza with a diameter of 13 4/9 and a square box that is 13.45 inches across. Write 13 4/9 as a decimal. So if you're converting a number, like a mixed number, like 13 4/9 to a decimal, you really only need to worry about this part right here, okay? We know that this is going to equal 13 point something. Okay, maybe it repeats, maybe it terminates, but we know the 13 is going to be there. So don't stress about it. Just go ahead and convert 4/9 to a decimal. So again, I'll do this one more time. The number on top goes in the house. The number outside goes outside the house, and then add your zeros. 9 goes into 4 0 times. 0 times 9 is 0. 4, bring down the first 0, make sure we have our decimal there. 9 goes into 40. I don't know, 4 times? 4 times 9 is 36. 40 minus 36 is 4. Bring down the 0. Up, I have 40 again. Again, it's going to go in 4 times. 4 times 9 is 36. And hopefully at this point, you guys see what's going to happen. I'm going to keep getting 40 minus 36. which means these 4s go on forever. So 13 4/9 in decimal form. Remember, we're going to keep the 13. And we only put a bar over the part that repeats. So our answer is 13.4 repeating. Got it? I'm going to skim. I only got a couple minutes left here. I'm going to skim through real quick. Oh, it was 13.4 repeating, which is smaller than 13.45. So yes, it will fit inside the box. And I think those are all the types of questions you're going to see. Yep, so I'm gonna leave it at that. Again, most of the decimals you've been used to in the past are what we call terminating decimals. They end, right? 1/4 is equal to 0.25. It ends. 1/2 is equal to 0.5. It ends. But now we have, these 1/3 and these 4/9, and you get stuck in these loops. And it's really important to see the long division to understand why these numbers never stop. Okay, hopefully this video is helpful. Make sure to ask lots of questions in class. It's a great opportunity this year to ask more questions than you ever have before. See you guys in class.